Principles Show Daily Podcast by and for you.
Hey everyone, welcome back. Ready for another deep dive? Today we're tackling something pretty big, actually, tiny. Microplastics. But don't worry, we've got some potentially awesome news on that front too.
That's right. We'll be looking at a pretty amazing potential solution.
Yeah, we found this article from China Daily, and let me tell you, it's got me feeling hopeful. But before we get all into that, just a super quick reminder for anyone tuning in for the first time.
Right. Microplastics.
Yeah, they're these teeny tiny pieces of plastic, like way smaller than a grain of rice.
And they're everywhere. Seriously, everywhere.
Like in our water, our food, even the air we breathe. It's kind of freaky.
And the problem is they're so small, they slip right through our filtration systems.
Which is, well, not great.
Not great at all. They end up in the environment, in animals, and yeah, even in us. And we're only just starting to figure out what that actually means for our health.
Okay, so not exactly a cherry topic, but that's where this China Daily article comes in, right? They're talking about a potential breakthrough, a way to actually remove these microplastics.
Exactly. And it's pretty innovative stuff.
Okay, lay it on me. What's the secret weapon?
Biodegradable foam.
Foam? Like soap suds foam?
Not exactly. This is a special kind of foam, and it's designed to act like a magnet for microplastics.
Hold on, so they're fighting plastic pollution with more plastic?
Not quite. That's where it gets really interesting. This foam is made from some pretty surprising materials.
Okay, I'm intrigued. Hit me with it.
Chitin from squid bone, and cellulose, which you find in plants, like cotton.
Squid bone? Wait, seriously?
Yep. They're turning to nature for inspiration, basically.
So it's like they're fighting plastic pollution with seafood byproducts.
Pretty much. And because it's made from these natural materials, the foam itself is biodegradable.
So it won't become another pollution problem down the road. That's good.
Right, it breaks down naturally.
Okay, so sustainable and all, but how does it actually work? How does squid bone foam grab onto these tiny plastic bits?
It's all about structure. Think of it like a sponge, but with super tiny holes. It's incredibly porous. And those holes, they create tons of surface area for the microplastics to cling to.
So more surface area, more places for the microplastics to get trapped, like a microscopic net.
Exactly.
Clever. So have they actually put this foam to the test? Or is this just a cool idea in a lab somewhere?
They've done real-world testing, and the results are impressive.
All right, drum roll, please. How impressive are we talking?
They tested it in all kinds of water. Irrigation water, lake water, sea water, you name it.
Okay, get to the good part.
Across the board. Nearly 100% removal of microplastics.
Wow, that's insane. Like all the microplastics just gone.
Pretty much.
Okay, color me impressed. But what happens to the foam after it's all loaded up with microplastics? Is it a one and done kind of deal?
Nope, it gets even better. It's reusable.
Wait, really?
You clean it and use it again.
Wow, sustainable, effective, reusable.
It's shaping up to be a pretty amazing solution.
Okay, I am officially on board. But let's not get ahead of ourselves. This all sounds amazing, almost too good to be true, so...
What are the potential downsides?
Well, that's where things get a bit more complicated. For starters, even though the materials themselves are sustainable, we got to think about where we get that much chitin. Squid bone isn't exactly an unlimited resource.
Yeah, good point. Scaling this up to meet, global demand, that's a whole other challenge. What about cost?
Yeah, cost is definitely a factor. I mean, it's probably cheaper than some alternatives, but we need to think about who can actually access it.
Right. Will this be something only, fancy water treatment plants can afford? Or could regular people use it too?
That's a big question. Ideally, this would be accessible to everyone.
Right.
But realistically, there are going to be some hurdles.
Like making sure it's affordable for developing countries too, where plastic pollution can be a huge problem.
Exactly. It's not just about developing the tech, it's about making it work for everyone. And then there's the question of what do we do with it after it's been used? Oh, right. Even though it's biodegradable, we can't just toss it anywhere, can we?
Nope. Got to think about the whole life cycle. How do we collect it? How long does it take to break down? Does it break down completely in all environments?
Yeah.
Lots of things to consider.
Yeah, we wouldn't want to swap one problem for another.
Exactly. It's all about making sure it's truly sustainable from start to finish.
Well, it sounds like the researchers are aware of these challenges, which is a good sign.
Yeah, it's not just about making a cool invention. It's about making sure it's actually good for the planet.
Responsibility. That's the word of the day.
Yeah.
Okay, I want to go back to the squid bone thing for a second.
Squid bone?
Yeah, it just seems kind of poetic to me. Using a byproduct of the seafood industry to clean up plastic pollution.
Oh, I see what you mean. Full circle.
Right. Like, the fishing industry is a big contributor to the problem, and now they're part of the solution. Kind of cool, right?
Yeah, it's like nature is showing us the way.
Using what we already have instead of creating more problems.
Exactly.
And who knows what other surprising solutions are out there. We just need to get a little creative.
Totally. This could be just the beginning.
Right. This squid bone foam, it's like a stepping stone to a whole new way of thinking about pollution.
Right. Bio-based materials, mimicking nature. Who knows what's next?
Okay, I'm getting excited, but gotta rub it back down to earth for a sec. I know we can't just rely on technology to fix everything.
Oh, absolutely. We've got to change our behaviors too.
Right. Reducing our plastic use in the first place, being mindful of what we buy and how we dispose of things.
It's a two-pronged approach for sure. Innovation and individual action.
And that's where spreading awareness comes in.
Totally. The more people know about this stuff, the more they can make informed decisions.
And hey, that's what we're trying to do here.
Absolutely. Sharing knowledge, sparking those aha moments.
Power to the people. Okay, so back to the article. They mentioned something about a patent application. What does that mean exactly?
Well, a patent basically protects their invention, make sure no one else can just copy it.
Makes sense. But it also means they're probably thinking about bringing this to market, right?
Yeah. Could be a sign that we might actually see this foam on the shelves someday.
That's huge. So it's not just a scientific breakthrough, it's a potential business opportunity.
Right. And that could be a good thing. If it's profitable, there's more incentive to, make it widely available.
Right. Got to make it accessible, not just another luxury item.
Exactly.
Finding that balance is key. So to wrap this all up, what are some of the potential challenges we need to consider with this technology? I know we talked about some already, but...
Well, like we were saying, even though this foam's designed to target microplastics, what if it accidentally grabs onto other stuff in the water?
Oh, right. Like, what about the good stuff? Could it mess up the ecosystem?
That's a possibility we need to look into.
Yeah, wouldn't want to solve one problem and create another.
Exactly. We need to be really sure it's not causing any unintended consequences. And then, thinking long-term, how do we make sure this technology benefits everyone?
Right, back to that accessibility question.
Yep, with that patent, it could end up being something only wealthy nations or companies can access.
And that wouldn't be fair, especially since, the people most affected by plastic pollution are often the ones with the least resources to deal with it.
Right. So it's important to think about how we share this knowledge and make sure it reaches the places that need it most.
So global collaboration, not just a technological fix.
Exactly. And this foam, it's from microplastics, but
Yeah.
What if we could use this same idea for other types of pollution?
Oh, interesting. You're thinking bigger picture.
Yeah. What if we can make foams that absorb heavy metals from, say, industrial waste, or even capture greenhouse gases from the air?
Whoa, that's next level.
It's all about taking these principles, the sustainable materials, the porous structure, and seeing how far we can push it.
It's like one discovery can open up so many possibilities.
Exactly. It's a ripple effect. And it's pretty awesome to think that this squid bone foam could be the catalyst for even bigger breakthroughs in the future.
Seriously, it's enough to make you feel hopeful, even when things seem kind of bleak.
Right. There are so many smart people out there working on these problems, coming up with innovative solutions.
It's inspiring, for sure.
And this foam, it's a good reminder that we don't always have to reinvent the wheel. Sometimes the answer is right there in nature,
Yeah.
just waiting for us to notice it.
Squid bone, who knew?
Right. So as we wrap up, I think the main takeaway here is, yeah, this foam's amazing, but it's just one piece of the puzzle. We can't rely on technology alone to fix everything.
We gotta do our part, too.
Absolutely.
Yeah.
Reduce our plastic use, make conscious choices, and support companies that are doing things the right way.
It's all connected.
It is. And every little bit helps.
So to everyone listening, thanks for joining us on this deep dive.
Yeah, thanks for tuning in.
Hopefully you learned something new, and maybe you're feeling a little more optimistic about the future. We'll see you next time.